Hello everyone. Today I will discuss about Poisson distribution. Poisson distribution is the topic of Poisson distribution is under the discrete distribution. Now we will prove what is the mean and variance of Poisson distribution. Mean is mu, variance is also equal to mu. What is mu? Mu is a parameter. Now, for to prove mean and variance is equal to mu, we will take the PMF value. PMF means probability mass function. Probability mass function or the PMF of Poisson distribution is equal to e to the power minus mu, mu to the power I by I factorial. The values of I starts from 0, 1, 2. Now, with the help of this probability mass function, we will prove the value of the mean of Poisson distribution and value of the variance of Poisson distribution, which is mu. Now, how to prove this? Now we know the mean of any discrete distribution. What is the form of discrete distribution? In discrete distribution, there is capital X is a random variable which is discrete random variable, and we take the spectrum of capital X which is 0, 1, 2, 3 up to suppose infinite. And the PMF, this Fi is called the probability mass function. The PMF of Poisson distribution, let 0 respect to F0, 1 respect to F1, F2, F3. This form is called discrete distribution. Now, the formula of mean in discrete distribution, if the spectrums are like x0, x1, x2, x3, then the formula of mean will be summation xi fi. That is, we will multiply our spectrum with our PMF, then x0 f0 plus x1 f1 plus x2 f2 plus x3 f3 in this way. Now, if we remove this x from each the spectrum and take the spectrum of x as 0, 1, 2, 3, then this formula will change into I summation I fi. I from 0 to infinite. Now what is fi? We know fi is our PMF and the value of PMF is e to the power minus mu. E to the power minus mu, mu to the power I by I factorial. Now with the help of this I factorial, we will remove this I equal to 0 to infinite, I e to the power minus mu, mu to the power I factorial can be written as I into factorial I minus 1. We can cancel this I now. Now since there is factorial I minus 1, so I will change from 1 to infinite. Now e to the power minus mu summation I equal to 1 to infinite mu to the power I by factorial I minus 1. Now we will put one by one the value of I. First we will put I equal to 1, so that will be mu to the power 1 by factorial mu to the power 1 by factorial 0 plus. Next we put I equal to 2, so that will be mu to the power 2 by factorial 2 minus 1, that is 1, plus mu cube by factorial 2, mu to the power 4 by factorial 3 up to infinite. Now you can see that this factorial 0 is 1 and in this bracket mu is the common portion. So we can take mu as a common part. So mu will be outside the bracket and this portion will be 1 plus mu by factorial 1, mu square by factorial 2, mu cube by factorial 3 up to infinite. Now we know the exponential x is 1 plus x by factorial 1, x square by factorial 2, x cube by factorial 3 up to infinity. Since e to the power x is equal to this, so we can write this bracket portion as e to the power mu. So this is equal to e to the power mu, mu into e to the power mu. Now e to the power minus mu and e to the power plus mu will be 1. So the final value of mean is equal to mean. So in this way we can prove that in Poisson distribution the value of mean will be mu. Now we will prove the value of the variance. First, what is the formula of variance of x in discrete distribution? Formula of variance of x is expectation of x into x minus 1 minus m into m minus 1. Now what is this m? M means mean. Mean means expectation of x. Now we have already proved that the value of mean of Poisson distribution is mu. So m, the value of m is mu. So only this value is unknown. M is mu, only this value is the unknown value. So we will find only this value, which is expectation of x into x minus 1. Now you can see that mean or expectation of x, if it is expectation of x, then the formula will be I equal to 0 to infinite I fi. If expectation of x equal to this, then what will be expectation of x into x minus 1? If we put x into x minus 1 in place of this x, so that will be expectation of x into x minus 1. If there is x, then the formula will be I fi. So if there is x into x minus 1, the formula will be I into I minus 1. That is, the formula of expectation of x into x minus 1 will be I into I minus 1 into fi. I from 0 to infinite. Again, we will put the value of this PMF fi, which is e to the power minus mu, mu to the power I by I factorial. Again, in the same way, with the help of this factorial I, we will cancel this I into I minus 1. I into I minus 1 e to the power minus mu, mu to the power I by factorial I can be written as I into I minus 1 into factorial I minus 2. So we can cancel this I into I minus 1. That is, we get e to the power minus mu. I starts with, since it is factorial I minus 2, so I will be 2 to infinite. Okay, so I will be 2 to infinite e to the power minus mu, mu to the power I by factorial I minus 2. Now we will put the value of I one by one in this summation. First we will put I equal to 2. Sorry, this portion is here. Only mu to the power I by factorial I minus 2. If we put I equal to 2, we get mu square by factorial 0. Next we put I equal to 3, mu cube by factorial 1. I equal to 4, that is mu to the power 4 by factorial 2. I equal to 5, that is mu to the power 5 by factorial 3 up to infinite. Now here mu square is the common part. So we take mu square outside the bracket and get 1 plus mu by factorial 1, mu square by factorial 2, mu cube by factorial 3 up to infinite. Again, this is the series of e to the power mu. So we put e to the power mu here. And e to the power minus mu, e to the power plus mu will be 1. So that will be mu square. This is the value of expectation of x into x minus 1 is mu square. Now put the value in variance. So variance of x is equal to expectation of x into x minus 1 minus m into m minus 1. Now this value is mu square minus value of m is mu into mu minus 1. Now if we break this, we get this cancel. So the final value of variance of x is mu. So in this way you can prove the Poisson distribution, the variance and mean of Poisson distribution are equal and the equal value is mu. This is very important topic for your examination. So in this way you can prove. Thank you so much.